Okay, now at this point, I've got to go back to being old-fashioned. No, this is the better one. Let's take this and let's finish out. I'm trying to find a formula for this guy, for Sn, for the series, the sum of the first n terms. So if I take out a factor of Sn from the left-hand side, what does that leave me with on the left-hand side once I factor it out? Just on the left-hand side.
Oh, just 1 minus R.
Yeah, there's one of them there, and there's R lots of them there. So it'll be 1 minus R. Are you okay with that? Okay.
Wait, so explain that again, please.
Yeah, are you talking about this line to this line?
Yeah.
Okay, so I just want to do some factorization. I don't want Sn minus R. I just want that guy by itself. So if you think about like changing the subject in any normal algebraic situation, I just want a single one of them. So I've factorized it out. In a similar way to how you might factorize, say, if I had 5x minus x squared, you could factorize an x out of that, couldn't you? Right? So you'd write that as x outside of 5 minus x. You divided each of those. And that's exactly what I've done here. Is that okay? It's just a bit messier because I've got all these letters flying around. Some of you might be able to anticipate what I'm going to do on the right-hand side. How can I simplify it? I can factorize this common factor of a this time, so I take that out. What does that leave me with? 1 minus, careful, r to the power of n. And I'm just one step away from the formula I was after, right? I just want this by itself, so what should I do to both sides?
Divide by 1 minus R.
Divide by 1 minus r. So here is our formula, put a big box around it. The sum of the first n terms of a geometric progression is this. It's a bit of a monstrous looking fraction, but this is it. This is what you will find waiting for you on your reference sheet. The formula is there. Doesn't explain where it comes from. Doesn't tell you what a is. What's a? First term. Doesn't tell you what r is. What's r? Common ratio. Doesn't tell you what n is. It's the number of terms. But this is the formula that it gives you. Okay. Now, quick note before I let you have a go at using this. Just like the sum of an AP, there's more than one way to say the sum of a GP, right? For example, it's the same formula, but I could dress this up differently. If I multiplied the denominator by -1, if I multiplied the denominator by -1, what would you end up with? What happens to this when you multiply by -1?
-1 plus R.
Yeah, -1 plus r, which I could write in a more nice order. I would write it as r minus 1. Do you agree with that? If I did the bottom by -1, I should do the top. So what happens when you multiply the top by -1? What happens to these guys in the brackets?
R to the n.
Just like these swapped order, these also swap order. So you could write the same sum in this way. These are not two different formulas. It's the same formula, just dressed up differently. Now, I'm not going to tell you just yet why you might be interested in writing it this way versus that way. You're going to discover it soon enough. But both of these, and in fact there's a third form I'm not telling you about yet because it's less important, but both of these are ways to calculate the sum of a GP. Can we quickly do an example? Can we quickly do one? Before I had written 2, 6, 18, ... Okay? So perhaps I want to know what's the sum of the first, say, 7 terms, right? The sum of the first 7 terms. I don't even know what the 7th term is, but I don't need to be able to use this. Help me fill it in. What's a in this case?
2.
2, fantastic. I'm going to, for reasons that will become clear in a second, I'm going to use the second formula. Have a think about why I might use this one rather than that one. What's r? What did we identify?
2.
It's, in this case, it's 3. That's the common ratio. How many terms did I say I was interested in? 7. I wrote it right there. Okay. 7 minus 1. And then on the bottom I've got 3 minus 1. So now I can just sort of simplify a little bit. How convenient. 3 minus 1 is 2. So I'm going to cancel there. 3 to the power of 7. Okay, guys, help me out. 3, 9, 27, 81, 243, 729. I'm pretty sure it's 2,401 is the next one.
2,187.
I was thinking of powers of 7. I'm an idiot.
187.
2,187. Take away 1. So now I have an answer. Okay? Yeah, sorry, I get my powers mixed up. All right, now, I'm a maths teacher, not a calculator. Now, what's brilliant about this is that I don't need to, I can avoid so much work. I don't even know what the 7 terms are, but I can still already work out what they add up to. If you think back to that truck dropping off gravel before, you know how we were like, I know the total distance. I might know the total, and being able to calculate things on the basis of that directly without worrying all the intervening terms can really be a time saver. Okay? So I'm going to hit pause there. Oh no, I tell a lie. Can you tell me why? Why did I use this one rather than this one, which was the one we actually landed on? Any suggestions? Say it again, Perrin?
Wouldn't it have given us a negative denominator?
Okay, was this what you were thinking, Tyler? So I could have done everything with this first formula, right? But do you notice I'll have a 1 take away 3? You're like, gross. And you're going to have a negative here as well. You have 2 negatives. They'll cancel. They'll still give you the same answer. But I might as well avoid the negatives if I can. Mo asked what the third form was. I wasn't going to tell you. The textbook does show you what it is, but I'm going to show you where it comes from. I'm going to take this like so. That's right. Okay. I'm going to take this and you know when we had a look, you've got your piece of paper there. I'm just going to borrow this one. You know how we turned the sum of an AP into its other version? Do you remember how we did that? We took advantage of the fact that we knew what this guy was. Do you remember that? We knew what that was? Thank you, Sean. What is this for a GP? We just wrote it down, right? A R n minus 1, which is hiding, kind of tucked away in here, isn't it?
Yes, sir. Factor it.
Totally is. We can factor out one of the r's, right? It's n minus 1 times r. Do you agree with that? It takes a second to see it. You got to think about your index notation there, right? Minus a on r minus 1. So that guy there, see that? That's the last term. So I could, if I wanted, write it like this. This formula it turns out isn't as useful, which is why I didn't show it to you. It's not on the reference sheet, but it's true, just like the others are true. Does that make sense?